Okay, so imagine you're out to coffee with a friend, and the two of you are just chatting up a storm, and you're talking about, I don't know, animals, like all your favorite animals. And then after a while, one of you mentions horses, and suddenly your friend is like, "Oh my god, I love horses," and like can't stop talking about them. And you're just a little bit confused because the whole subject of animals kind of gets taken over just by the subject of horses. Well, if you examine your conversation graphically, you can analyze that at some point X, your friend leaped off the curve of the conversation and went off on a tangent about horses. And that's all a tangent line is, it's just a line that touches a curve at one point. Hi, I'm Daniel Rosen, and today I'll be talking about with you how to approximate the tangent of a curve. So for this example, we're going to use f of x equals x squared over 2 as our equation in question. The graph looks like this. And to start off, we're going to have to pick a point on the graph where we want to find the tangent line. There's not just one point. Like, if you think about it, there's hella points, infinite amount of points along a curve where a tangent line exists. So for this example, we're going to find the tangent of the curve at x equals 2. Okay, so how do we do this? Well, step 1 is to differentiate our equation with respect to x. And above you can see me differentiating this equation so that now we find what f prime of x is. And lucky for us, it's really simple, it's just x. So the derivative of the function at x equals 2 is just 2. Alright, so step 2 now is to solve for y. Here we're going to refer back to our original equation. We know what x equals, but do we know what f of x equals? Well, it's as simple as just plugging it in to the function and finding what f of x equals at x equals 2. And it turns out to, conveniently also be 2. Okay, now our third step is just to put all these elements together and graph the line. So here's the equation we're going to use when we graph the line. It should look familiar to you. And here's the information we have. We know that x equals 2. We know that the derivative at that point is 2, which is our slope. And we know that y at that point equals 2 as well. It's almost like I planned that. So if you plug in all those variables and solve for y, you're going to end up with the equation of that tangent line in graphing form. And if you want to see what it looks like in real life, voila. This is a line that only touches the curve at x equals 2. Has a slope of 2 over 1, and you can't see it on this graph, but it has a y-intercept of -2. So it has all the properties of a tangent line that we were looking for. I really hope you enjoyed this video. Thank you so much for watching, and now I hope you can have a clear understanding of what a tangent line is, how to find it, how to graph it, and of course the calculus behind when your friend goes off on a tangent in casual conversation.